What does Africa have to do to become energy independent? Constant power outages and lack of electricity are some of the stereotypes that Africa is known for when it comes to energy. The energy debate has been here for a while now. However, for Africa, our voice in this debate has been more like a murmur, if not a whisper. So how do we change the narrative? Suppose the energy problem is split into two: energy generation and energy storage. When it comes to energy generation, we've got this covered here on the continent, since Africa is well endowed with lots of energy generating potential, ranging from solar to natural gas. All that is left is how to harness and store the energy from these sources. When it comes to energy storage, the battery still remains the energy storage medium of choice. However, to date, there is no battery that can either last long enough or store enough energy to power Africa's villages towards energy independence. We must therefore invent alternative forms of energy storage, such as storing hydrogen in liquid organic hydrogen carrier systems. Liquid organic hydrogen carrier systems are not only environmentally safe, but also allow us to store energy for longer without energy losses. And the stored hydrogen can then be used further to generate electricity or even as a fuel. It is this concept that was going to be explored in the coming Tokyo Olympics game, where hydrogen was going to be used both as a source of electricity and as a fuel. Africa has many cutting-edge researchers with the capacity to design new materials for storing energy, such as liquid organic hydrogen carrier systems. However, to get to these next-generation materials in time to meet Africa's energy demand, computational modeling is the most promising way to augment existing experimental approaches to material science and design. By harnessing the capabilities of quantum mechanical calculations and high-performance computing resources that we have here on the African continent, we can, for instance, dramatically shorten the product-to-market life cycle of these energy storage materials. This therefore makes computational materials modeling no longer a luxury, but a necessity. So how is this done? To accomplish this, we use fundamentals of basic sciences, mainly physics and chemistry, to construct computational models of these materials, and then use quantum mechanical calculations, which is mathematics, to understand the behavior of the atom. This is because the atom is the smallest unit of matter, and hence the basic building block of any material. Thus, having a fundamental understanding of the behavior of the smallest unit of matter allows us to accurately predict the next generation materials. However, these quantum mechanical calculations are computationally expensive, hence require the use of high-performance computing facilities or supercomputers. Fortunately, the Center for High-Performance Computing in Cape Town, South Africa is available for free for all African researchers and academics. All that is needed is internet access and a login device. So, if Africa is to be on the path towards energy independence, there is a serious need for many more computational material scientists that can keep up with our homegrown experimental researchers within the continent. This is because we still do not have enough students pursuing careers in basic sciences, mainly mathematics, chemistry, and physics. Basic sciences understandably lose out to other nobler professions such as doctors, teachers, and even engineers when it comes to safer careers of choice amongst young people. However, the fourth industrial revolution is here, and with it comes the need for those like me who still desire to solve real African problems using basic sciences. The stigma associated with mathematics, chemistry, and physics here in Africa is real. When one declares interest in pursuing these subjects, you must contend with questions like, where do you intend to work? Or which future will you have with pursuing a career in basic sciences? It is my hope from this talk that you now have a clearer answer to some of these questions, which is, you can do everything.